So now we have finally closed with the protocols and REST versus SOAP services. So now we move on to a different topic, and in this lecture I would like to cover with you some conceptual principles of service-oriented architectures and also some, let's say, design patterns. So up to now, we have been dealing with essentially protocols or syntax. So it's just a description on how the things has been designed and why. I hope that also we have been able to conceive you a little bit of some of the reasons. The part that is starting now is a little bit more, let's say, free, in the sense that we are not talking about syntactics, we are really talking about patterns. So as you know, and principles. So as you know, these are not something that you have to follow. The protocols you have to follow. This one is something that in reality is just you can use them as guidelines. So we think that these are, let's say, a number of useful guidelines, and the patterns in software engineering are essentially these one, guidelines. So there are common problems, and there are people who have been facing this problem and have come up with some kind of design partners which can help. But it's open, so if you decide to do it in a different way, it's fine, it's not a problem, but you have to explain us why, okay, why you have done that. Why, in the sense, what is the reasons, why do you think that it's better, your solution, than the, let's say, the patterns of design. So we start with what is called, and we will focus in the remaining part on basic SOA. So basic SOA, it's by now we have covered all the aspects. The first diagram is essentially about the roles in the service without any implementation or specific definition of the protocols. So these is the triad. There is a service client, the service provider, and usually there is a service broker that is in between. The service broker can be very lightweight in the case of, let's say, small application, small service-oriented application. It can be a very quite substantial piece of the middleware in more enterprise and realistic cases. And the following, now you know it by heart, is the map of a possible implementation of the service-oriented architecture. So the architecture is not bound to any particular protocols in its concepts. It's free, you can decide how to do it. And this is one. The so-called web service nowadays is more called big web service or SOAP-based web service implementation, when you have the protocols that we have seen, SOAP for messages, WSDL or WSDL for interfaces, and eventually UDDI is one of the standards for the service registry. But now that we have covered all this one, we step a little bit back and we go back maybe to the one of the first lectures that we give about the principles, what is really service-oriented architecture, and let's see if we can be a little bit more precise now. And what is really service-oriented architecture? We can have, there are many definitions, and some, for instance, are based on the purpose, and this is one of the one that I have selected for you, and we can discuss a little bit about that. Other ones are more technology oriented. So let's start with a more conceptual one. So let's say essentially the purpose or the reasons. And service-oriented architecture, it says from this model, is a paradigm. So paradigm is always one of these words that says a lot of things. So it's a way of, is a pattern for organizing and utilizing distributed resources and capabilities that may be under the control of different ownership domains. So I've highlighted there 3 points of this definition: paradigm, resources, and capabilities. And so it has to deal with a set of principles, of concepts. This is the paradigm. It has to do with some kind of assets, okay, something that it has a value, can provide a service, and has to offer some functionality. So this is very, let's say, generic, the conception, the high level of abstraction. And these are three components of the overall architecture. The other things that is written there, which is different than other architectures, because these things essentially you can say could be also in, for instance, object-oriented architectures. These three things. The new things is that it's distributed. Object-oriented architecture that don't need to be distributed. In place here is distributed. There are these other two properties, and it can be under the control of different ownerships of domain. I think this is really very important. So the so-called service-oriented systems will cross domain ownerships, meaning that you are the owner of a particular application and you're using someone else's application. This can be really, let's say, the case of completely different organization, or sometimes inside the same organization there are different roles, the customer relationship office, the billing office, the accounting, and the division inside. But it's each one of these owner is the owner of that particular domain, and it's exposing its capabilities and its resources through this domain. So this is one of the important part, enables communication among different parts of the organizations, that need to work together. Remember that service-oriented architecture is born as an integrator of enterprise applications, so enterprise application integration. It is not only a technology, it is also a way to how to structure this technology. So let's give a more, let's say, software engineering definition, maybe a second try at this definition. And it could be something like this. Service-oriented architecture is a software system, so it's an information system composed of a collection of software services. And then we have to define what is a software service. A software service has to have a value, so it's an asset, is a resource that is deployed at a given specific endpoint. So here we are a little bit more technical rather than the generic definition of the purpose of before. So we need to have an endpoint, could be a URL. Typically, as you know, it's a URL, is a uniform identifier. And also it is continuously maintained in the sense that it's always available. Okay, that's another property, technical property, that is more connected with service level agreement. So if part of your application is relying on someone else's service, you must have some kind of agreement on the level of service, which are usually called SLAs, service level agreements. Otherwise, I mean, okay, your application will break down, obviously. So it's something, this is also an important property. So usually services, the software service, they must have explicit contracts. A contract could be a technical contract, and this is, for instance, the WSDL interface or the REST interface in case of REST services. But it also has to cover non-functional aspects like service level agreements. And obviously, software services are supposed to be reusable in the sense that the whole idea behind it is really, they are really useful if they can be reused more than just for your ad hoc application. Otherwise, it's much better just to build your class and have it in your application. So this is not given, a given is something that we have to thrive. We have to make use, and the best things to do it is just on the design time to really identify, and we will see in the rest of these lectures and also in the remaining ones, how we can do this to identify the proper level of granularity on one end, of functionalities, of composability that the service must have in order to to reach this goal, which is to increase the reusability and so overall flexibility and efficiency of your software systems. So that's for the definition. It's some of the many definitions. It's the one that we like the most, essentially. But you will find on the various literature around or references on the web also different other types of definition, but essentially, I mean, these covers the majority of them. Apart from the definitions, there are a number of, in the various books and literature, there are a number of principles that also enable us to identify what is a service-oriented architecture. And these are the keywords, and some of them are really, how can I say, buzzword, like loose coupling or reusability and composability, because these are essentially very popular in computer science in general, in academia. But let's see what they are. So here they are: loose coupling, abstraction, reusability, and composability. These are all important, let's say, properties of the service-oriented paradigm. What do we mean with loose coupling? The idea here is to minimize, it's loosely, is not connectionless. At a certain point, you need to connect with another service, so you need some small coupling, but it must be very lightweight, very limited. The way to do that is to essentially base all your different parts of your application through protocols, and we have seen the protocols, and through messages. So there are no direct access to somebody else's implementation, but all the communication is passing by this, let's say, more or less standard interface, HTTP commands for REST, SOAP messages, and WSDL interface for SOAP-based web services, so that you are decoupled from your other functionalities or services. And we have, again, also to try to do this. It's something that, on one hand, increases the complexity of your system, because having to pass through these protocols and messages, maybe it's much, let's say, less performant than call directly a database. On the other hand, you gain in flexibility, reusability, and decomposition in the first one, and then recomposition if you want to aggregate the same services in different ways. So it's something that you have to pay, but it's the fundamental principle, I would say, of a service-oriented architecture. The abstraction, we have talked about that, is that it's connected with loose coupling, but it's also a property connected to the fact that you don't have to know the inner working of the other people, of the other enterprise services. So you are only bound to the particular interface or contract that you have, and not with the details. So it's very easy to change, to improve, to evolve your services. If you are sticking with the same interface, you just make the service better, faster, more efficient. You maybe add functionalities, this is allowed, but you have to keep the contract with the previous interface. And this allows, obviously, the reusability, which we have thought about that. So clearly, I mean, you build a service if you think that not only you and only your application is going to use it. You build the service if you think that it's something that you want to promote as reuse. The last part is, again, a principle, is also a property, is the idea of all these paradigm is that at the end you will program by combining together different services towards an end. So you are, it's part that you have to, it's a properties of a principle that you have to have in mind from the beginning. So your service is going to be put inside other, together with other services in an application. So the ability to compose and not to break under this composition is also an important issue. So we go now slightly, in details of some of them. The loose coupling and the abstraction, we know how to do it. The underlying client logic and underlying service logic are loosely coupled when they are essentially binding only to their interfaces. This is, I'm kind of repeating myself here. And so the client on one hand, let's start from the client, is only aware of the service interface, so is oblivious, so doesn't know anything about the service. And on the other hand, the service does not need to know anything about the client, so does not need to interact with the client logic. So the logic is taken out of the two aspects and is put inside in the underlying logic. So clearly, as I said, you are paying a bill on this one because you are not directly connecting the two things. You are going through this schema of protocols, and the interaction is purely through messaging infrastructure. And this also allows a number of nice features, like the service does not break down, the client can break down, because if the message is not delivered, it will break down. But then you have to, all the, let's say, logic and quality of service and exception, you have to deal it on the client side, independent on what is happening. And once the message is sent, the client has no control over it. So this is the loose coupling of the things. This goes now towards the idea of achieving reuse and composability. So the first two parts were about loose coupling and abstraction. The best things to achieve reuse is, again here there is a very big similarities with object-oriented programming, or maybe component programming, which is the different steps, in which the reuse is best if you are able to identify easily both the entities that are involved in your application domain, let's say business domain, and to be able to identify both the entities that are important and the interaction between these entities that needs to be modeled again as messages. So here is very generic advice saying that it is important, that's probably what I need to say to have the majority of the emphasis, that all the times that you are developing services and a service-oriented application on top of that, or an architecture, you have to strike a good balance, and this is up to you. The best you do it, the more efficient and the more, let's say, flexible and prone to evolution your information system will be, between atomic operation and one single service application. So these are the two extremes of this range. On one hand, you can write one monolithic application with no services, in which you have one services that does everything, customer relationship management, and you have everything in this big service. It's not a service at that point, it's just a standalone application. On the other hand, you have atomic operation of reading the individual data of your system, like first the name, then the surname, then the age, etc. You have to find the right balance between these two extremes, and the best way is just to try to aggregate in atomic operation of individual read of data in some, let's say, entity or also document-centric messages in which you are conveying enough information for that particular entity so it can be processed and maybe it can be aggregated above. Because obviously, if you do millions of atomic operation, your system becomes very slow and unperformant. If you do one single service application, there is no need for a service-oriented application. So this first part, which wants to be just a generic overview of this paradigm, what is the value proposition? Because at the end, one paradigm, one architecture is bought by customers, being them programmers on one hand, or enterprise or institution on the other, if it has a value proposition. The value proposition is probably here in the bottom. I had to go back and see what was that really, that image is money, because at the end is money, most of the time that drives the value proposition. So, and here are a number of, I'm listing, I'm going up on the other way, I'm listing some benefits that could be in, let's say, that are put forward as value proposition for this kind of architecture. For sure is the idea of increasing reuse and sharing of resources. Another big point is to increase the flexibility of individual business processes, and this can be done by the service-oriented architecture, by the fact that you are adding new functionalities, or you are reconfiguring, composing existing services with new services, and that's the flexibility, which means also support to the evolution. And then there are some very, let's say, value proposition related really to cost, reduce integration cost, reduce time to market. You can reconfigure your system. Let's say you are a phone provider, a telecom provider. You can reconfigure your system quickly and evolve them rapidly in the market. The phone companies has been one of the major players in the service-oriented architecture implementation inside their system. And hopefully increase customer satisfaction, because if you are flexible, if you can change faster, then you can increase the customer satisfaction. So how do you do, how can you reach this? The idea is organize your information system into reusable services with explicit dependency and contracts. In this way, you increase the reuse, sharing, and flexibility, and then understand individually, try to give value for each individual services in order for them to be used in your integration environment. Okay, let's now go to a more technical, not as much as you do in the laboratory, but a little bit more technical. Let's see what are some kind of architecture and components. Let's talk about the components. So this is a very simplistic view, but it helps us in understanding the various items. So in one simplistic view, there is a number of services that are available either on the web or inside your intranet or in your system. On the level of the services, there is typically a service description repository, because the clients, the users, the service requesters must have access to these, and they are decoupled. This can be in different machine. The service repository is in different machine. The service repository can be a very simple one. It can be a more standardized one like UDDI, but also in the case of REST services, you must have somewhere the documentation about the interface and the APIs of this service repository. At the top level, there is a number of applications that are based or uses some of these services or all of these services, depending on the kind of application. So these are the elements of the components of the architecture. Services, there is some kind of middleware component, a service description repository that helps you in finding the services and using them. And then there must be some kind of glue that allows this system to interact. This glue is usually called the enterprise service bus, and it's a middleware, essentially component, that connects the services with the application, with other services like repositories, and with other kind of external services which are not meant there. They have been done. So The enterprise service bus is an entity that it's needed, and it can be as simple as a web server. In the case of REST, you don't need anything else than just a web server. So, because REST, as you know, relies on HTTP, and that's one of its strong points. And so it's nothing very complicated, or it can be a very complex piece of middleware that you need to install where the service is provided and where the service is, let's say, used on one hand. There are commercial products, there are open source products, and some of the most used development suites like NetBeans or Eclipse, they do provide you with this kind of lightweight services. Then there is also a commercial one. There are vendors like HP and other Microsoft that are really also having a full-fledged product with much more services, not only the repository, but also quality control transactions. And in this case, you can use that one. What is the point is that the more high level or complicated it is, the less your system is open, is only working on that particular platform. If you are using just a web server, then your system, your services are working with any kind of infrastructure, current infrastructure. So the enterprise service bus, we will use a very simple one in the laboratory, we will use it. And another component that we mentioned before we go to the main component, which is the services, is the service repository. We also will need a service repository if your application has to be run also in the assignment, in the final project from everywhere, and that's what we will ask. We will have to use a very simple repository, maybe not UDDI, but a place where we have the collection of all our projects. And if we are able to do it in the right way, you might also be able to use services of your colleagues eventually, if we have a common infrastructure, for instance, for this course, so here at the university. And I mean, I'm not going to go into the detail of this one because these are the things that we have covered in the service repository. We could use the standard, or we could use just a database in which we just store all the information, where the WSDL file is, where other service contracts are, access rights, and information about this one. Usually, the repository is used for at development time. This is the let's say 90, maybe 90-something time of the percent of the time you're using it at development time. So it's something that you use at design. You are designing, you want to know what are your system, your services, or you want to develop a new services. You enter it in the repository so that you can use it later. You know that there is this vision, we covered it, that it could be useful, and there are a number of, let's say, framework and projects on this one, to be used at runtime, because it would be used, for instance, to substitute on the fly a service with another one if one endpoint is not available. This is a very simple use. Other is just if you are not able to find one service, you switch to another one which has similar characteristics. And these similar characteristics are the complicated things. So now we are at the, let's say, the core part. So of the three components that we have seen, the bus and the repository is something that is outside of your control. They are there, you use them. The services are the ones that you as programmer, we as programmers we have to develop. And we have either to develop or to use. That's the nice part about these, let's say, programming paradigms. You can just also reuse someone else's services if it is fine with you. So as always with conceptual model, one thing that is useful is a classification of the potential services. And here I repeat myself by saying that this is only one possible way of classifying services. Is not the classification of the services is a common used classification of services that can be used and the whole idea behind this classification is to support the programmers at the design phase, okay? So don't take it as a Bible, obviously it's not. It's just a possible classification, and I would say a potential usable classification. If it is usable or not, you will find it in your assignments, maybe, but in reality, in real life development projects. So what does it say is this hierarchical classification? Let's start from the bottom. So at the bottom, you find what are called, so in place of a generic service, you just call them basic services. And these are the foundation. They represent the basic elements of a specific domain. You are in the bank, you have some specific basic services. You are in e-health organization or a health organization, you have a different one. Travel organization. Specific to the particular, typically business or commercial or logical domain. And we will see there are two flavors of this. Obviously, again, it's a arbitrary distinction, but it's sometimes useful to distinguish between data-centric and logic-centric services. And these are the bases. We will go there in more details. I will give you some example of these elements. The next level is the so-called intermediary service. They don't deal with data. So this one, usually they deal with the specific domain, and they all usually, especially the data-centric one, they deal with the data. The logic-centric, they deal with the logic associated to the data. And the intermediary service is a level is a successive level in which they deal typically with problems related with integration and technical integration issues. So they deal with gateways between technologies. They deal with adapters to specific formats. Maybe you have applications that are using the same data, but they are representing the customers, for instance, which is the typical example, in different ways. So you're dealing with adapting one kind of data with another. They don't act directly on the database, typically. They act on a higher level. And they can, well, we'll see what is facades, is a pattern in which you are combining one or more services together, or you are adding functionalities to existing data. Well, obviously you can always do it directly here, but sometimes you don't want to do that, because sometimes you want to maintain that your initial basic service will provide a particular function, and then there is an evolution, but you want still to maintain that function. So in place of changing that service, you're just adding functionalities to this service at a higher level. And usually these are stateless, in the sense they only process data and they don't care about a particular state in which they are. So they get data, they output data, they process the data, they change the data, they adapt the data, they add functionalities, but they don't do anything about, they do not maintain the state of the evolution of the various components. So the next teams, as you can imagine, is the one that are dealing typically both basic services and intermediate service is a good, let's say, design principle to make them completely stateless, because that's how you implement the loosely coupled principle of services. So they get some input and they give you some output without any connection with what came before and what is going to be done next. At a certain point, you have to put the state of your business process, and this is done typically at the process-centric level. And here is where you might want to organize the previous layer services in something which is more structure and maintains the state of one call after the other. There is a split between the process-centric, the business process of a particular organization, division, slice of your domain, business domain, and the public enterprise services in which in place it's something that it's exposed to others which are outside your domain. So these are the so-called public enterprise services, and they are, as it says, they're interfaces for cross-enterprise integration. So it could be between divisions, but usually the divisions are inside here. It is mainly the connection with other enterprise when you have you want to do business-to-business applications. At the top part of this classification, it's something which is not a service, but it's something which is always, let's say, needed, which is the application front end. The idea is that we'll provide you with some hints on how to do this in the laboratory course. Somehow you have to have an interface, mainly with humans, typically with humans, but also with business to business, or it could be other application. So the last part essentially is not a service, but it's the active elements, is the one on how you're going to interact at the end. It can be also a terminal kind of view, a line command, because if your architecture is completely based on services, the only thing that you need to do is just to call, and that's the real, let's say, basic level, the most easy one, but very primitive. Or it could be, typically it is a web application nowadays, but it could be a standalone graphical user interface, could be a mobile application, it could be whatever you want it to be, and whatever it's needed in your particular place. And for the case of this course, we are not asking, since in this course we are not giving you any let's say, knowledge about graphical user interfaces of web application, we cannot essentially ask you to do a specific one. So for us, at this level of application front end, it could be as simple as a line command. Clearly, it's going to be a little bit awkward, and you have to remember all the names of the various things. Or it could be the majority of your colleagues in the previous years, if you have enough knowledge about web application, a web application is the easiest way to implement this front end, because talking about web services, the web application, it's obviously the most, let's say, standard solution, but it could well be also some application, Java application with Swing, or your preference software development language. Or if you have some already some prior knowledge, it could be a mobile application, Android or iOS system. So that's the application front end. So I think I will do a break here, and then I will continue by going in some details of the of these individuals. So we will make some examples, what it is a basic service, what it is an intermediate service, and things like that. And then we will go about explore a couple, or actually three style of architectures that could be useful for us in order to build a service-oriented application.